Hello, geometry folks. Today we're going to be talking about parallel lines and transversals, which is another new kind of line that will be new to you. So what we're going to need is a pen or a pencil, your notebooks or composition notes, and then two foldables today, and then we can get started.
So now that you've glued in your pink chapter divider, you can go to the right-hand side of your notebook on the next page and start taking these notes. So write this down. Do not write this in your foldable. Just write this in your notebook. Parallel lines and transversals. Transversals. In geometry, a line segment, or array that intersects two or more lines at different points is called a transversal. So in our diagram, we see two parallel lines, line L and line M, and they are being cut by the transversal line AB. The line AB is an example of a transversal and it intersects lines L and M. Notice on the diagram that there are different angles being formed at all points of the intersection. So you see that we have angle 2, 3, 4, 5, 6, 7, and 8. Another way we can write the definition of a transversal is by saying, in a plane, a line is a transversal if it intersects two or more lines, each at a different point. So let's look at an example. We have two here, and lines can be cut by transversal, and they may or may not be parallel. So let's look at this first one. We have parallel lines, like our last slide, L and M, and we have this transversal line, T, that is intersecting or intercepting line L and M. I want you to notice the notation here that I have circled in purple. How we read this notation is line L is parallel to line M. Hopefully that's familiar to you. If it's not, that's totally okay. We're going to learn that and use that a lot this year. So now our second example is non-parallel lines. See how line B and line C are at one point on the left going to intersect each other if they kept going on forever and ever. So R is a transversal for B and C, but the lines, however, are non-parallel or not parallel. So how we show that in notation, again, I'm circling it in purple, is this way, what I circled in purple, and how we read that notation is line B non-parallel to line C. So still continuing to write in your notebook and not on your green foldable, we can write that two lines divide the plane into three regions. The region between the lines is referred to as the interior. So if you look at our diagram below, the yellow spot that's labeled interior is the interior of the two lines. It's pretty easy to remember, inside the two lines interior. And the two regions not between the lines is referred to as the exterior, which is exactly what you would think it would be. It's on the two outer sides of the parallel lines. That is in blue, and we labeled that exterior.
All right, now let's look at four special kinds of angles. When a transversal intersects two lines, 8 angles are formed, just like we see in this picture. Angles 1, 2, 3, 4, 5, 6, 7, 8. And we've seen this picture of the two parallel lines with a transversal cutting it with those 8 angles formed. Okay? But now we're going to talk about how these angles are given special names. And not just like an individual angle, there's 4 pairs of special angles that are given special names. So the first one would be alternate interior angles. So alternate interior angles are on opposite sides, alternate sides of the transversal, but they lie between the parallel lines. So that makes sense. Opposite lies inside the parallel lines. So inside the parallel lines L and M, we have angles 4, 3, 5, and 6. But we want opposite sides of the transversal. So 5 and 3 is a pair, and then 4 and 6 is a pair. So we can write those down under alternate interior. The next special pair is alternate exterior angles. So same idea, except now they lie on the outside of those parallel lines, but they're still on the opposite sides. So we could have our angles that we're looking at from this picture are angle 1, 2, 8, and 7, because those are the 4 that lie on the outside of those parallel lines. So opposite ones would be 2 and 8, and 1 and 7. So 2 and 8 and 1 and 7. So those are those special alternate exterior angles. And then we have same side, or also called consecutive interior angles. So what those are angles that are on the same side of the transversal, but they lie on the inside of the parallel lines. So again, the inside of those parallel lines that we're looking at, those angles are 4, 3, 5, and 6. Now we want ones to be on the same side. So we have 4 and 5, and then we have 3 and 6. So 3 and 6 and 4 and 5 are those pairs of same side interior angles. So make sure you get those numbers down. And then last but not least, the corresponding angles. Corresponding angles are the same location or in similar spots with a group of angles. So let me show you an example before I get too confusing on you. So corresponding angles would be like 1 and 5. See how they're both on the left side of the transversal, and then they're above line L and line M. So that would be an example of a corresponding angle. Another example of a corresponding angle would be 2 and 6. They're both above those parallel lines, and they're on the right side of the transversal. Another pair would be 4 and 8, and the last pair would be 3 and 7. So we have 2 and 6, 3 and 7, 1 and 5, and 4 and 8. So make sure you get these angle pairs written down in your notes.
So now would be a good time to grab your green foldable. I know mine's white, but it should be the same writing and yours should be green. And we're going to start with writing in on the inside of this. So we'll get more understanding of these vocab terms and we'll get more practice with what that means with algebra as well. So you'll see what I mean in just a second. And we just went over these 4 types of angles, but we'll go over them again. So we're starting on the left-hand corner of your foldable with alternate interior angles. Alternate interior angles are the angles between the two lines and on opposite sides of the transversal. Alternate interior angles are congruent when the line M is parallel to the line N. So in our on the right hand side here, find the value of x given m parallel to n. We just found out from the definition that these alternate interior angles are congruent. So we can set up our algebraic equation as 64 equals 2x plus 4. And from here, it's just a two-step equation, right? So we subtract 4 from both sides. We get 60 is equal to 2x. Divide by 2, and x is 30. As simple as that. So we're going to start using these ideas of alternate interior angles to set up equations, and we'll see how some of the other types of angles can help us set up algebraic equations as well. Moving on to alternate exterior angles, which are angles outside the two lines on the opposite sides of the transversal. Remember, exterior is on the outer side of those parallel lines. And just like alternate interior angles, alternate exterior angles are congruent when the two lines, L and M, are parallel. So just like our last one, we're going to be able to set up this angle equal to this angle because of our definition of alternate exterior angles. So since they told us it was given that M is parallel to N, we can make that equation. So 6x plus 10 equals 4x plus 24. So we can combine like terms. I'm going to subtract 4x from both sides, subtract 10 from both sides all at the same time. These things are going to go away. Working from left to right now, 6x minus 4x is 2x equal to 24 minus 10, which is 14. Divide by 2, that's our final step, and we get x is 7. Corresponding angles then, now moving to the bottom left-hand corner of your foldable, are angles that are on the same side of the transversal and both above or both below the lines, the parallel lines. So corresponding angles are congruent when line M is parallel to line N. You're starting to see a pattern that all of these angles are congruent. So how do you think we're going to set up our equation? We're going to put them equal to each other. So remember, corresponding angles are the ones that are hardest to identify, but in our picture, they're the only ones that are labeled, and they're both on the same side of the transversal, and they're both either below the line, and they're both below the line. So we know that they're corresponding angles, and we know they're congruent. So we can say 6x plus 10, whoops, I don't know what I'm writing here. 6x plus 10 equals 4x plus 30. So again, I'm going to subtract 4x from both sides, subtract 10 from both sides, all at the same time. 10 is going to go away, 4x is going to go away. 6x minus 4x is 2x, equal to 30 minus 10, which is 20. Divide by 2, x is 10. And last but not least, consecutive interior angles. Remember on our previous slide that was same side interior angles, and they're the same thing. So angles that are on the same side of the transversal and between the lines or in the interior of the lines. So consecutive interior angles, whoa, this is different. They're not congruent. They're supplementary and have a sum of 180 degrees, because that's what supplementary means, when line M and N are parallel, or when line M is parallel to line N. So our equation is going to look different from the last three examples we did. So we said that these two angles, these consecutive interior angles, are supplementary. So how we have to set up our algebraic equation then is 3x plus 5 plus 2x plus 15 equals 180. And we should be pros at setting stuff up like this, since our last entire chapter was basically doing that. So now we just have to combine like terms and solve for x. 3x plus 2x is 5x. 5 plus 15 is another plus 20, equal to 180. Subtract 20 from both sides. We get 5x is equal to 160. Divide by 5. And we get x is equal to, 32. So you don't have to write this little summary down, but I just wanted to recap the notes that we did together today on our video. But when these lines are parallel, alternate interior angles are congruent, alternate exterior angles are congruent, consecutive interior angles are supplementary, remember, and then corresponding angles are congruent. So if these lines, note down here, if these lines are not parallel, these relationships do not exist. So be careful when doing problems. If these lines aren't parallel, we can't assume any of these postulates.